Hello and welcome to Measures of Variation. So we're going to cover a lot of things in this video. First of all, range, interquartile range, standard deviation, and we will also touch assumed mean and assumed variance in this topic. Okay, let's get started. Okay, so the range is basically the numerical difference between the highest and the lowest numbers of a set of data. So for example, I have a data, an ungrouped data, in which I have the highest value of 19 and the smallest value of 6. So to take out the range, I will do 19 minus 6 and 13 will be my range. Okay, now let's take a look at grouped data. Okay, so let's take this continuous data for an example. So we've been given continuous data and we've been given the first and the last set of data, and there's values in between, but we don't have that mentioned right now. So there is a certain range under which this frequency falls. So this frequency can be anything in between this range. Okay, so we are told to find the greatest or the least possible range. So for it to be the greatest, we'll assume that this falls into the lowest and this falls into the highest. Okay, so 169.5 minus 149.5 will give us 20 centimeter, which will be the greatest possible range of this continuous data. But if we want to consider, if we want to find the least possible range, so we will consider this to be a part of this frequency to occur near 150.5 and this frequency to occur near 168.5. So we get the least range. Okay, but because this frequency is not 0, we have to consider this whole range. So we have to consider one of the values of between these two. Okay, so we have considered 168.5, which is the least value of this, and 150.5, which is the greatest value of this, to find the least range of this continuous data, which is 18 centimeters. Okay, so now let's take a look at quartiles and percentiles. So a quartile basically divides a set of data into 4 parts. The first quartile, which is the lower quartile, is the first part of the data. The middle quartile or the median is which is the data which divides it into 2 equal parts, and the third quartile is the third part of the data. So for example, this is the data I have. The Q2 will be around here, the Q1 will be around here, and the Q3 will be around here. So it divides the data into 4 equal parts. Okay, now what is the interquartile range? The interquartile range is Q3 minus Q1. So this is the Q3, this is the Q1. You subtract the values of these and you will get the interquartile range. Okay, so now let's look in how to find the quartiles in a group data. So first of all, we'll have to either draw a cumulative frequency graph or we'll be given one. So this is what it looks like. So this is basically the frequency and it is cumulative. That means that it keeps on adding, and this is the x values. Okay, so let's say we have to find the first quartile, the lower quartile. So we have a total frequency of 400. So we'll use the formula 1 upon 4 of into total frequency, which will give us 100. So we'll locate the value of 100 in this table. So the 100th frequency, we will trace it and we will find where it meets the graph, and then we'll find the corresponding value of it, which is nearly 18 in this case. Okay, for the middle quartile or the median, we'll use the formula half of the total frequency, which will give us 200 in this case. Then we will again trace 200 and find where it meets the curve, and then locate the corresponding value, which is 24. And then similarly with the third quartile, the upper quartile, which will be 3 upon 4 of the total frequency, which is 300. We'll trace that, and that gives us nearly 30 in this case. So to find the interquartile range, we'll just simply subtract the upper quartile from the lower quartile and we'll get something like this. Okay, now let's move to percentiles. Okay, so percentiles are like quartiles, but like quartiles divide data into 4 equal groups, but percentiles divides the data into 100 equal groups. So let's say that I have this set of data and I have to find the 60th percentile. So this is basically the formula. The percentile you have to find is x. 100 is the total number of percentiles there are, and sum of frequency. So there are 10 numbers, so this will give us that the sixth value is the 60th percentile, and 1 2 3 4 5 6, so we can say that the 32 is the 60th percentile. Okay, so now that we've done percentiles, we can say that the quartiles are basically the 25th, 50th, and the 75th percentiles. So this is Q1, this is Q2, and this is Q3. Okay, so in group data, how do we find the percentiles? So basically we have CFG, a cumulative frequency graph, and we are supposed to find a percentile. So basically we divide that by 100, the percentile we're supposed to find, and multiply it by the total frequency. Okay, so we get the value, for example, 475th value. So we again trace the 475th value, see where it meets the curve, and find the corresponding value on the x-axis, which is 80 in this case. So 80 is basically the 95th percentile in this group data. Alright, so what is a box and whisker diagram? So this is basically an example of a box and whisker diagram. This is the box and these are its whiskers. So basically this is the whole set of data. We have written it down. We should use a graph for drawing this, and the units, for example, if this was centimeters, the units should be mentioned on it. So this basically shows the three quartiles: the lower, the median, and the upper quartile. Okay, so we can see that the median is 11 in this. We can find the range of this data, the largest value minus the lowest value. This represents the largest and the lowest values, and the interquartile range can also be found. Okay, so now let's see how the quartiles can show if a data is positively or negatively skewed. So if we say, if we see that this quartile, the one between Q3 and Q2, is greater than this quartile, the one between, let me use a different color, the one between Q2 and Q1, so we can say that it is a positively skewed diagram, because if we draw a bar graph of this, so the data will look something like this. It will be it will have more frequency towards the greater amounts, so this means that it's a positively skewed data. Okay, so now if the data is greater in the difference between Q2 and Q3 is greater than the difference between Q3 and Q2, this distance is smaller than the distance between Q1 and Q2. That means that if we draw a bar graph of this, it will have more high values towards the low value end. Okay, it will have more frequency in the low value end. That means that it's a negatively skewed data. That means that it has more less values. Okay, now for it to be a symmetric data, both of these have to be more or less equal. So the distance between Q1 and Q2 and the distance between Q2 and Q3 must be equal. So if we draw a bar graph of this, the data will look something like this. So this will basically show that it is a symmetric data.